Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and I'm joined as always by Nick, founder of Postgres AI. Hey Nick.
Hi Michael, how are you?
I am good. How are you?
Very good. Fantastic.
Oh, great. What are we talking about this week?
Not about AI.
Yes, for a few. We have a detox.
Everyone is talking about AI, so we are not going to talk about AI.
Great. So what are we talking about?
Let's talk about plan flips, and it's quite a complex topic because I feel Postgres lacks a lot of stuff, and I'm not sure what it needs to have in future to be better. And there is a lot of criticism, including a recent wave of criticism against Postgres in this area, right? After some incidents from one company. The company name is Clerk, right?
Yeah.
Clerk.
Or Clark.
How do you pronounce it?
I say Clark.
Clark. Okay, that's interesting.
But
so it's E, but
that
you
might
say
be a...
I don't know.
Yeah.
Okay. Yeah, and there was an outage or series of outages. I don't know.
Yeah. Quite a
on
long
February
one.
19, 2 weeks ago, and I'm. As usual, kudos to all companies who share experience. This is great.
Yes.
They shared experience. They had a blog post with timeline and root cause analysis to some extent. And then I saw on Twitter, discussions which looked like Postgres is not good enough. Let's choose better systems. Because look what you might have with Postgres.
Yeah, look what can happen and...
Yeah. Might happen, can happen.
Exactly,
Yeah.
something quite innocuous. So they've said the plan flip was maybe not the root cause, but the thing that took them down, and due to insufficient statistics. But yeah, they're an infrastructure provider, right? So they do authentication, and if auth is down, that means all of their customers are down. Yeah, exactly. So this was a huge issue for them and for all of their customers. They are very wary of things that can change unexpectedly, understandably, but equally lots of services that need extreme high availability run on Postgres. So how can they do it? I think that would be a good discussion.
So, in my opinion, their root cause analysis is halfway done.
Yeah.
And naming plan flip a root cause is not all right. Why? Why 5 whys?
Mm-hmm.
Right? You know this approach.
Yeah, I think Toyota.
Yeah, basic approach for root cause analysis is ask why until you cannot answer at all. Mm-hmm. So their analysis was saying like, the problem happened because Postgres triggered analyze, obviously automatic analyze by AutoVacuum process, which caused plan flip. So they did only 2 steps in this 5 why approach. They said, okay, what happened? Why we are down? Because statistics changed. Why statistics? Because plan flip. Why? Because it was triggered by AutoVacuum. 2 of 3 steps. But you can go deeper, right?
Yeah.
You can go deeper.
I think there was one more. I think they did increase statistics target, for example, to make less likely to happen again. But there still are more steps for sure.
Yeah, they increased default statistic target?
No, maybe not default, but for the table, I think.
Okay.
Or for the column, I forget which.
Yeah, it's either column or global. Anyway, that's interesting because in my opinion, there are different plan flips, different kinds of plan flips, and I'm still trying to figure out for myself. But if you have plan flip when suddenly like it flipped after recalculation of statistics, that's interesting because that might happen. This is actually a difficult type. This is hard type of plan flip. But question is, why it happened only now, not 1 hour ago, for example?
And what's to stop it happening again?
Yeah. And this is interesting, right?
So I have some thoughts on this specific case, but I think it might actually be useful for us to go back to basics a little bit and define what do we mean by a plan flip and what the normal causes of them. And I think this is a little bit of a special case that should be interesting and might be completely avoidable, I think. But a lot of cases aren't avoidable, and I think that's an interesting discussion. But yeah, in terms of plan flips, I wanted to ask you, do you define them only when they're bad? Because we have a cost-based optimizer, right? The reason we can flip query plans is because the planner has choices, and it makes those choices based on estimated costs of doing different join algorithms or different scan types. But flipping is part of its design, right? The same query running on different data as the data changes perhaps should use a different execution plan. It would be faster to use a different execution plan. So flipping is designed, it's deliberate, but the idea is it flips to a better plan when the data suits that.
So sudden plan change is normal, while
grow. Yes.
Yeah.
But when people say plan flip, it feels like they're only ever talking
negative
about
connotation.
bad. Yes, exactly.
Yeah, because this is when it changes to wrong state. Because the planner sometimes have mistakes.
Yes,
right?
Or misestimations. Yeah.
For example, if you have random page cost 4, which is default, I saw many situations when we have 2 candidate plans which have very similar cost under these circumstances. So for this data and what we have in PG statistic, and for these settings, including random page cost 4, which is default, I saw the cases when there are 2 plans. One is obviously wrong. For example, sequential scan for huge table. And another is obviously right, which is index scan. I'm remembering some simple cases, like simple in terms of it's obvious to a human or even AI that this plan for this table shouldn't be chosen because it's a sequential scan on the whole table. But since, for example, Postgres thinks that random I/O is so expensive, it suddenly chooses sequential scan plan instead of index, and you don't notice until some point when these costs, they are very close to each other, and then suddenly when a little bit more data comes to the table and analyze happens, sequential bad one wins, and that's it. And this we usually solve by adjusting random page cost, telling the planner that please don't choose sequential plans. I know we like Tomasz Wondra has great proof that maybe random page cost 4 is not bad. Maybe even it should be bigger. But I have brain split here because I see what his reasoning makes sense theoretically, but what I saw in production proves the opposite. I saw these plan flips happening when just like suddenly, and it was like some ticking bomb. It was like it was sitting there, and then boom, like suddenly the planner chooses the sequential scan, and we are down because the time's out, right?
Yeah, I have a theory about this. I've been thinking a little bit about it, and I think it's like Tomasz's work is very good in theory because he cares about the optimal time to flip. He cares about how much data do we need to be reading before a sequential scan is faster. But in practice, like with large tables, the flipping point is not that important. The main point is we almost never want to request that much data. Often, especially in OLTP, we want very small selects. We're only selecting one record or only a very few number of records. So the flipping point we want to put so far out of sight that even if our row estimate is really bad, because often it's a combination of two things, right? It's not just the cost of doing random access, it's also how many rows do we expect to be reading? And if that's out by a lot and the cost is high, those multiply together and suddenly Postgres is thinking, do you know what? I might as well scan the whole table here because I'm expecting to read so much. But if we decrease the random page cost, we get away with the bad row estimate. So I think you can fix either and get towards it. But if you do both, then you massively decrease your chance of this kind of issue.
I hear you, and this in my mind connects very well to the topic of OLTP versus analytical versus hybrid, because there are good advancements in the area of analytical queries processing for Postgres in various ways. And there is also, I strongly believe that there is a very simple case called pure OLTP. Pure OLTP means that we need to serve users who are humans mostly, maybe, and they have human perception. Our very first episode was about this. 200 milliseconds, this is when they recognize something is already happening, and if it's significantly more than 200 milliseconds, it feels slow, which means we need to have our queries below 20 milliseconds because one web page consists of multiple queries, usually roughly 10, say 10, like some guess, right? It means we need to be below 20 milliseconds. In this case, by no means I want any sequential scan be applied. Never. Like, I don't want it. Like, just forget about sequential. I want to turn it off completely.
I would counter that sequential scans on tiny tables are fine, right? If it's only got 100 rows in it, but also an index scan on that table would be fine as well because it's still only got 100 rows. So the times where sequential scan is best don't matter anymore because an index scan, whilst being less efficient, or even a bitmap scan, would be absolutely fine, even if it's twice as slow or even 5 times as slow because it's such a tiny table.
But we also have different other. There is also bitmap scan, index and heap scan. So it's like in the middle. And how the planner thinks about the cost, it's interesting. So I think how we tune some service for OLTP, and this is obviously OLTP. People didn't want this service to,
of course.
We definitely want very strict timeouts. I think 15 milliseconds, it's old. We should go down to 10 seconds. 10 seconds. So statement timeout should be 10 seconds. Even transaction timeout should be 10 seconds for radical. Let's introduce concept of radical OLTP. Yes, you have some workload that needs to be analytical, and some people can wait or some background jobs. Yes, create index taking a couple of hours. It's also a different story. But if it's pure OLTP mobile app, which many people depend on, put transaction timeout and statement timeout to very low value, be very strict, and just cut those queries which start running longer. In this case, if you, for example, have a bunch of them happening, there is a chance that on powerful machine you will survive. If you don't have it, it will be a snowball effect of many sessions being stuck and running in sequential scan or something like not optimal, and it will be consuming resources.
The other thing it might do is it might more quickly point you in the right direction as to what's causing the issues. Like you start.
How to diagnose. Let's maybe. I think I'm pushing us to some like problems and resolutions already. But let's go back. You raised a very good point about what plan flip is. So in my head, it's also like this is negative term. Plan flip is a sudden plan change in the wrong direction when like basically the planner chooses a plan we don't want, like sequential scan or maybe bitmap scan, which is timing out, for example.
Yeah, I think that it might even be worse than that. I think it might even be like it's noticeably worse. If it flips and it's 1.1 times slower, I think most people don't really care. Yeah. If it's double or triple, or it's like it takes you from being 90% CPU to 100% CPU, if it crosses that threshold, maybe again it's the Thomas episode we did on performance cliffs. If it's a cliff for you, then...
Yeah. In my opinion, performance cliff term is different, and it's macro term. While plan flip is micro term. It's like it's just one session, and we see suddenly execution of this query became much worse. It was 10 milliseconds, suddenly became like 1 minute. Boom. And obvious example is like we had an index scan, but suddenly the planner... and usually it happens in complex queries, right? So joins, subqueries, CT, multi-stage, like it's something complex. And then boom. While performance cliffs for me, like it's macro level, like some lightweight lock contention happens and didn't happen and then suddenly it happens, right? There is no official terminology here, right? So I'm just reading some blog posts and trying to adjust my own mind to them mostly, right? So this is how I feel. So plan flip is negative term, right? So we don't want it to happen. And we started with difficult example. This company obviously experienced this difficult example. And my question to them is like, what random page cost you had? Did you have statement timeout idle transaction timeout, maybe not related in this case, and transaction timeout. So some safeguards which would protect from a huge wave of sessions which experience this bad plan to be executed. And also, what were your auto vacuum settings? Right. This is.
You think that's relevant?
Before we go to defaults, before we go to an increased number of buckets with statistics target, these are macro settings we need to keep in mind, and this is what
I had another. I had a different thought.
Yeah, sure.
This for me felt like a data skew issue, and so they mentioned the column in question was 99.9996% null values. And this query was looking for the not null values, of which there were still 17,000. So we're talking about billions of records, but only 17,000 were not null. In cases like that, like where you've got such a data skew, you could be looking at, like for those columns, you could be looking at increased statistics, or often you want a partial index on a column like that, right? Because you don't care about indexing the billions of null values, you only care about indexing the not null values. And once you've got the perfect index on that, I know it could be a more complex query where you want different columns, but if you've got those columns in the index at where the value is not null, then actually the planner's almost certainly going to choose that because it's such the perfect index for that query. And you don't even have to worry about misestimations. It's never going to pick a sec scan in that case.
Yeah. So we definitely lack information here.
Yeah.
Right? So we didn't see the plans. We don't know their settings. We even don't know the version. Right. So we can only guess. And again, there are difficult situations with plan flips. I saw quite difficult ones, and where obviously like everything was normal. But what I'm trying to say, you can get a plan flip because you didn't do good job configuring Postgres well enough and making and putting these safeguards for all TP workloads. And this is what we do, number one, with all the clients during consulting, and which also the clients who install our monitoring and checkup service. And this is like number one thing. We need to be, we recognize we are OLTP. The priority is to have the super fast queries. And we need to prepare basics, right? Unfortunately, they cannot protect us in 100% of cases. But if you have your auto vacuum not tuned, for example, you have this new, relatively new setting. I remember Darafay raised this topic. We didn't have auto vacuum insert scale factor, right? And auto vacuum analyze, there are two, right? So which triggers on insert, and by default it's 20%. And also we have old regular vacuum scale factor, which triggers on updates and deletes, also 20%. And for analyze, it's 10%, 0.10, right? Which means 10% of your table needs to be changed. If it's a huge table, it's a lot of data. And again, you're like this data skew, it's a good point. If you suddenly, you had one distribution, but suddenly like all the new records, they are very different. And you don't have properly tuned auto vacuum, you accumulate that data a lot. And then suddenly, after 10 or 20% of data changed or inserted, auto vacuum finally ran analyze. Suddenly we have a flip. If it happened earlier, maybe it also would be bad. It's actually a good point. Maybe still we need the statistics target, but we, like in my opinion, it's better to have more frequent process running on large tables. So statistics would represent actual data better, more often, right? To allocate more resources, to have more workers. This is what we do all the time with larger services. And unfortunately, we see, like I would say, 2 out of 3 clients coming. Most of our clients are startups which like have, say, database exceeding 100 gigabytes, up to 10 or 20 terabytes. This is like sweet spot for us, where they experience some problems already. And 2 out of 3 roughly have poorly tuned auto vacuum. Poorly tuned. And
only 2 out of 3 is quite surprising to me.
Yeah, this is my rough. I can check statistics
I
because
would
we
have
have a
guessed
lot
higher.
of data.
Yeah.
Yeah.
You need to update your statistics, reanalyze.
My internal, I need to ask AI to maintain statistics
I'm
on
not sure
this.
about that. Yeah.
Yeah. Anyway,
All right. But I
this
had a
is my
question though.
feeling. Yeah.
Default statistics target is like 100, and quite often see people increasing it to 1,000 when an issue like
Yes.
this happens, or at least for like specific columns. Other than increased analyze time, which is like important, but
Not a
not
lot
that
increased.
important for.
Yeah.
Yeah, and it doesn't increase that much, and also it's not that important for OLTP systems, right? Like it's a background thing. It can be like it's. I'm
Might be an
wondering.
issue during upgrades, though. During a little bit issue
Only
because
some types of upgrades, right? Because if you've got such an important infrastructure OLTP system, you're probably not going to be doing PG upgrade. Like you're probably not going to be doing those types of upgrades that care about analyze. You're probably going to be doing logical failover,
it
right? Like,
still needs analyze. Still, no. You create this
why?
logical replica. You need to analyze this replica.
But
Right?
not while you're like you don't have to be down during that.
Yeah, you are
That could
right.
be done while the other system's serving queries.
You are right. You are right. Yeah.
And the statistics will have been getting updated while it's being populated because vacuum will be running and analyze will be like, so it's not in the. So I was wondering, for really important OLTP systems, why not just boost the default statistics target everywhere and just pay that extra cost?
Did we raise this question with Tomasz Wondra or no?
I don't think so.
Maybe we raised it when he was on Postgres TV YouTube channel. I remember the opinion that 100 buckets, it's a lot. Right. This topic connects to partitioning for me. Because when I see a table with 10 billion records, like table like multi-terabyte in size, this is like already quite late. We should have it partitioned. In this case, we would have many tables, and at least we would have a localized problem. Only for this partition we have a problem.
And we would have, let's say it had 30 partitions, we would have 30 times more data in the samples because
different statistics,
Yeah.
So I don't know. I see people raise it. Okay, does it affect analyze? Yeah, it does. How much? We can afford it. Okay, set it to 1,000 globally. Okay. How to prove it helps or not? We need holistic analysis of plans, right?
Yeah.
So we need. This is actually we tried to do many years ago before like current state of art of like things with branching and so on.
Actually,
maybe we
I
should
disagree.
revisit this topic.
I've just realized I disagree. I don't think this is about on average improving things. I don't think this is a case of on average I want a slightly better execution plan. I think this is a case of I never want to completely flip to an awful plan. So it's about risk It's like mitigating the outliers, not about improving. I would actually accept slightly worse on average latencies.
No, I don't talk about average. I don't talk about average. I'm talking about complete analysis. When you have, for example, thousands of plans based on production, you have a clone of production, and using branching, you can create replicas and compare plans before and after the change. This is what if framework which we have with DBLab. And you can compare plans. There's a question how to properly compare plans at the ground scale. We talked about this before.
Yeah.
Our approach is just compare structure and cost and the buffers and also timing. But timing, it's tricky because it's volatile and so on. If cost changes seriously, this is already a signal to investigate what happened. If structure changes significantly, also a signal. Structure, by the way, maybe like you don't need the whole structure. You probably just need to access methods. Like you had 3 index scans, suddenly you have 2 index scans and 1 heap scan, sequential scan, right? So it's bad, right? So what happened? Anyway, this holistic approach is great. So you can have huge amount of plans, and then you have ability to do the change and compare before after. Again, I haven't visited the topic of default statistics target, particularly in this context, for quite a while, but it would be great to do it. I have a bunch of unfinished thoughts. This topic, plan flips, is unfinished in my head. Like I'm still like thinking what's better. So once again, you don't need average or something. It's a classic optimization problem. You want to optimize something, and you don't want everything else to degrade significantly. You say, I'm okay if something degrades like maximum 10% on some metric. There's a question which metric to choose also. But I want this to be improved. This is one thing. So we have framework, we don't have all the answers yet. The second thing is how to understand we are on the edge of flip or cliff, if you like, doesn't matter.
Yeah.
How to understand.
I actually don't know if this is important as much as how do we stick with what we've got.
I want to predict it.
Yeah, but I think it's really difficult to predict bad plan flips without also predicting good ones. There'll be so many false positives. If you think about how you would do it.
I forgot to mention that in our case, we execute on real database, full size, full clone, using database branching, provisioned very quickly. And we see not only planner, but executor and action, like realistic testing, right? Full-fledged realistic testing. We execute hundreds or thousands of queries, samples, properly collected. So, like, it's not we have 100 samples and 90 of them it's the same query ID. No, we like take query ID, we collect multiple samples for each query ID, and then we execute before and after the change. We developed this framework specifically to predict plan flips for major upgrades.
Yeah, right? Which is, it's slightly different, right? I think...
No, it's not different.
I think it's different. Do you know, I think why it's different is often people talk about plan flips in the context of, I didn't change anything and this thing just happened.
Yeah.
Whereas with a major version upgrade, you know in advance you're doing it.
Major change.
And you can look at... Yeah, you have this reference point of we changed something
have new engine,
big.
Basically.
Yeah. So I think psychologically, at least, it's different. I understand that in practice, there's a lot of the same harnesses.
So that's why I'm saying there are easy plan flips and there are difficult plan flips. Easy, it's when you did some action. You upgraded Postgres.
Yeah.
You jumped between 13 to 18, 5 versions, for example. There are new nodes in plans, right? Never existed before. So definitely...
New settings, new configuration parameter defaults.
In my opinion, plan flip analysis should be a part of major Postgres upgrade, and we have it for our clients. Yeah, we have it for our clients. It still requires some, like, it's semi-automated right now. I hope at some point we will fully automate it, and it should be automated, in my opinion. And it shines when you have database branching properly implemented. But there are difficult plan flips, like, to explain how to like properly categorize it, let's a little bit stop and think about what does it take into account when choosing plans. It's only 3 things. It's version, so which defines the version of the planner, basically, right? Which engine we are using. And the second, it's settings, not all settings.
Yeah.
My current vision is like the planner settings plus work mem. Why I'm saying plus work mem? Because the planner settings, there is a category. If you check PG settings, one of the columns it will be category, right? And there is a category called planner settings, but work mem is beyond. So plus work mem. And finally, the number 3 is PG statistic content. And that's it. It doesn't care about hardware or actual data. Right?
Yeah, true. It's not actually the data volume, it's how much data it thinks it has, which is the statistics.
Yeah, and if PG statistics is lagging, it might live in different reality. That's why I say I would prefer, it might still be wrong, but I would prefer it be wrong sooner and be closer to reality, right?
Yeah.
So when we change engine, it's obvious, we know when it happens. And before that, we can perform this plan flip analysis holistically according to our methodology. This is great. We can predict this plan flip and prepare a solution for it in advance. This is what we do with clients. Second, if we change settings, basically it's the same. We also know when we do it. For example, we are going to raise default statistics target globally. This will help to this plan. Question, how will other plans behave? We don't want them to degrade significantly, at least now. Same approach can happen. It can be applied. The third thing is PG statistic content is changing. Again, I would prefer it to be changing more often, like continuously changing. So more often, an auto-analyze should happen more often to reflect the current reality. For this, we need auto-vacuum tuning. And then how to predict.
Also, you missed something, which is we could gather more statistics. Like it's a sample, and we could increase.
Yeah, this is mitigation activity already. I agree that moving from 100 to 1,000 sometimes might make sense. And honestly, like, I don't have strong opinion here. I have clients with 100, with 1,000. In the past, I had clients who thought that going down to 10 is a good idea. I don't have them anymore somehow. So somehow right now, all the thoughts are to to direction of raising this,
I
not
agree.
to reducing this. Yeah, but I remember we had such discussions. Maybe we should raise it. Counterintuitive ideas sometimes win. No, we don't have it anymore. Anyway, two first things we usually control. We don't have self-driving Postgres yet, so we control it. And we can perform plan flip analysis if we have such tool. But
wait, there's one more thing. It's not available everywhere, but another thing that does affect this is, for example, if you're using hints with PG Hint Plan.
Okay, hints.
I think that's a
in
big
production?
topic, though. In production.
That's a great topic. Let's consider the exclusion because it's not a major approach right now. It's not. It's like very
is
rare.
That true?
Right now, I think. I hope so.
I think in other databases, this is actually often one of the main.
And you just try to open another gate to something, and I agree. Let's open it, but let's just finish with this second plan. While I think about second plan, again, if you change major version, you control it. You can predict plan flip. If you change settings, the same thing. You control it. You can predict.
Yeah.
If changing PG statistic content due to data changes leads to some plan flip, this is hard to predict. How to predict it? The more, when I think about it, I want to be able to check the second plan, or maybe first 5 plans which were almost winning, because in this case I can say, okay, I see the winning plan, current plan has cost say 500, but also there is a second plan which has cost 490, and it's quite close. If it's close, say below 20%, if difference is below 20%, I will start thinking, might it flip soon? Because this is why I want second plan.
I think this is incredibly tricky, though.
Maybe
it's simple, but for example, parameters matter a lot. Like per query, different parameters. If you get, for example,
parameters matter. Yeah, I agree.
Yeah, a huge amount. If you look at the solutions that SQL Server and Oracle have, bear with me because I think SQL Server and Oracle are a bit further ahead of Postgres on this. Probably maybe DB2 sometimes has some features in this kind of area, but the solutions they've ended up implementing are around forcing the freeze. So plan pinning.
Aurora
freezing.
has it. Postgres Aurora has it.
Interesting. So these are the solutions that other databases have ended up implementing rather than rather than trying to predict a plan flip. What they try and do is pin it or freeze it and then maybe require approval when it does flip. So instead of trying to predict it, they prevent it and then have it as like an opt-in thing. Maybe this changed for the better, but maybe you want someone to approve it first.
So there are several things here. You touched several things. First, depending on parameters, I agree with you. But in a system which is quite big, we have usually Pareto principle is working basically. A lot of workload is defined by limited number of specific plans, and this is how we have in our plan flip analysis. We have methodology to identify not only normalized queries from PG-star statements, but also particular examples, particular parameters. So we would reproduce exact queries with exact execution. So plans which contribute to workload the most. For example, contribute in terms of calls or in terms of total execution and plan time, right? So we want to cover 80% of workload in several directions, in several metrics, right? And this is the magic, how we collect those samples and prepare our testing query set for testing, so it would represent a majority of workload. Once we found a way to do it, there is some tail. Those queries are less important because if you just think about database time in terms of execution and planning, if some query is defines only minority of that time, even if plan flips, it wouldn't affect the whole cluster so much, right?
Yeah.
Doesn't make sense, right?
It does. And it actually reminds me of a different idea.
Actually. Maybe I'm wrong. You know what? It might be like, okay, now it's only like 1% of the whole time, and then due to plan flip, boom, it's already half of time.
It reminds me, though, of something that I think could help here. It's not in Postgres. Actually, maybe there's a couple of examples in Postgres core at the moment. But the idea that the plan is chosen and then is stuck to no matter what during execution. It could be, I think Thomas actually brought this up at the end of our call on performance cliffs. It could be adaptive at runtime. If it realizes it's doing, it's chosen a bad plan, like instead of sticking to it till the end.
We should invite Andrei Lepikhov. Andrei Lepikhov, who I think, who can talk about this adaptive query optimization a lot. I consider him an expert in this area.
Great. But do you see what I mean? If it's able to adapt during execution, maybe we avoid the issue, or at least it's way less bad when it happens.
Yeah, and also, like, to finish my thought, maybe this approach is wrong. Maybe if some plan which contributed only like 1% to whole database time now suddenly half. Because of this, I think my gut told me that we need multiple directions. One of the directions, when we collect this working set, we also order by calls, right? So it should be quite. So for a query which had the plan flip to influence the whole cluster so much that it causes downtime, it should be quite frequent enough, I think, right? If it's super infrequent, it should be fine. If it's not super frequent, it means that it won't occupy multiple backends in parallel, right?
Unless it gets really bad, yeah.
Unless you forgot to tune statement timeout or transaction timeout.
True.
Right? Yeah, and we have multiple vectors, and I think this is a good approach, good enough approach. Maybe it can be improved. So I'm very curious about this area, and I'm coming from practice.
Yeah, I do think there's still complex cases where you might have clusters of even the same query and pgstat statements could have 4 different plans that are actually all good. But let's say you're a multi-tenant system. Yeah. Maybe small customers look like, or tiny customers have this plan. Yeah. Huge customers that are typical have this plan. Huge customers that have this weird distribution, or maybe like healthcare customers look different for some other.
Yeah. And in analysis, again, I said like we collect multiple plans per query ID. Why multiple? Because of this. But so we like say top 5 for each query ID. We collect multiple of them, but all of them are like we take from this top n by H metric. So we try to capture like the concept of how influential this query is, and multiple plans might appear there. It would be great to have plan ID, right, and shift aggregation logic there. But we have query ID as the main tool.
I think PG Analyze, Lucas, I think, did some work on a plan ID.
I saw it, and I commented on LinkedIn, and it's a great work. Absolutely needed, I think. Yeah, it's great work. So then, like, if we have this, two questions, like, first, like, how to understand that some plan candidate is approaching and suddenly can flip soon? Because data in large tables, data usually is not changing too much suddenly. I agree with you.
It's like gradual, yeah.
Yeah, it's quite gradual. So the planar behavior for involving large tables, it's dangerous when we have 2 plans. This is my hypothesis, right? So again, like for me, a lot of open questions still. It might be like on the edge, and I want to feel this on the edge for each query ID or like for each plan. In advance, slightly in advance to be able to predict. I think someone recently had some work in this area to show plan candidates. I might be mistaken, but I saw something somewhere. I didn't dive deep. And the second thing is, in my opinion, hints and plan freeze are 2 great features. I put them to enterprise basket. Like this is, for me, it's enterprise thing. Because it's interesting, do we need hints, do we need plan freeze? For larger systems, probably we should have both. But I also understand the reasoning that it makes the system complex and it requires a lot of management. There is a price you pay. If you put something, you start to be responsible for it. You need to maintain it. And if you froze some plan, the same thing. You're responsible now, right? Basically, do we have capacity to manage it? Because maybe later it helps less, and maybe then it's not helping, but opposite. That's the problem. So
absolutely. But I do think it's interesting that these other databases, given the choice between the two, went in that direction. I'm not saying it's a good idea, but they've clearly thought about it, and there's some merit to it, and it's been working for many years. Of course with issues, of course with unintended side effects, but it is a solution, I think, worth considering. So yeah, this is good. I thought it was actually really interesting.
A lot of open questions.
Yeah.
I wish, I saw you send me this Postgres 19 improvements in terms of plan management and hint plans mentioned there. I wish Aurora team open source this. It's not Aurora specific thing. It's called APG Plan MGMT extension. APG Plan Management. Yeah. So it's a great thing, and I wish it existed in the open source ecosystem. I think eventually it should exist in open source ecosystem, because when I would use it, when suddenly we have plan flip, we know what plan we would prefer. And let's just pin it right now before we apply permanent solution, just to mitigate as fast as possible without any deployments.
But let's say we're Clerk, and we know we've got 15 to 20 really important queries. They're on the hot path for every single auth request. They're really frequent. They're thousands of times a second. We could deliberately pin all of those, or put hints into all of those to make them really unlikely. Pardon me?
Maintain. So this is different. So what I'm saying is temporarily pin before we apply permanent solution. What you say, permanent pin, and which means there might be some cost you will pay to maintain it.
Maybe, yes, but my point is, at least we then can guarantee it won't go bad. Maybe it will gradually degrade, and we can look at fixing. If it's going to degrade, I think it's more likely to degrade gradually instead of this all of a sudden. Which I think we can then fix Monday to Friday 9 till 5 instead of when there's a huge database outage.
And again, just partition your tables. I know it costs some effort, but with AI it's easier.
And gather statistics on the parent partition.
Yeah, which is another topic. It's fixed. Yeah. Lawrence Albe from Cybertech fixed it. I think it will be in 19.
Nice. Yeah. So automatic gathering of statistics. Nice.
Yeah, so it's headache during upgrades especially. I think it's solved now. Now it means
in the future.
19. Yeah. Great talk.
Nice one.
Enjoyed. Thank you.
Likewise. Thanks so much, and
see you
next
soon.
time.